So here is the battery from battery hookup. Here's the first version of the PCB. And here's the second version of the PCB. Observation on this second version, I was hoping to get twice as much battery capacity out on this version, but so far it hasn't turned out that way. I guess there's something internal to the BMS that keeps the batteries from operating truly in parallel, so I'm still researching that. So it may be more beneficial to just run one battery on the system. Well, we got another version of the printed circuit board for this BP TCA battery that I purchased from Battery Hookup. And here they are from Seed Studio. Let's take a look at them. Okay, so what we did on this rev is we added yet one more connector on the back so we could have two batteries plugged in instead of one. Now from part 1 of Project 1, we torture tested the BMS that's inside this battery to check where, at least approximately where the limits were. And the decision was it shouldn't be more than 4.3 volts input, charging input, and no more than 2 amps. If you charge it about a ½ amp and just let it go, you're probably just fine. So here's the new PCB, and we're going to go ahead and load it up. All right, that's the circuitry side, and back side is, there we go. First we're going to load up the IC, then the 1206 components, and then we're going to do the inductor, and then finally the connectors. So let's talk about the schematic. There you see our switch, 2 batteries, and the charge input, which uses a micro USB-B. There's our indicators, there's our OR diodes that allow the solar input and the USB to share the same line. So whatever has the higher voltage will be allowed to pass through to the batteries to charge them, and then on to the switch and over to the boost converter. We can double click on our symbol there, and there's the data sheet, MT3608. And part of your job is to learn how to read these specification sheets. Let's exit. Here we have the assembled version in 3D form. And you can see the large capacitors. There's the MT3608 boost converter IC. There's the charge input from solar panel. and the O-ring diode. Let's move over to the, okay, there's the charge input, USB-B connector. There's the LED charge indicator. We have our on-off switch. There's those caps. There's the boost diode for the boost converter. There's the inductor. And there's the output connector. There's a connector for the battery. There's a second connector. And if you use that second connector, make sure after you've soldered to clip off those leads so that they don't interfere with the JST connector. And there's the other O-ring diode, D4. We're going to take this boost converter, and to it we're going to have boost converter circuitry on here. But this time we're going to also include a protection circuit. Here's the charger, and here's a protection circuitry so that 18650 doesn't overcharge, over-discharge, or overcurrent. So let's put that together.